Hi, this is a tutorial regarding compiling the Delft3D fluid modeling software for Windows using Visual Studio and Intel's Parallel Studio XE, so Intel's Fortran and C++ compiler for Windows. This is a little bit challenging in the most recent editions of Visual Studio and Parallel Studio, and I'll explain why that is. But I just want to take you through the process and just and show you the steps that have to be taken. And I've provided a little bit of a software to make it a little bit easier to use these modern versions. So initially, I want to just go through the requirements that I needed to compile Delft3D. So firstly, you need to get hold of the code, and this involves a registration process, and then this will give you a subversion repository. The subversion repository, in general, you would use tags. So I've already gone and got one of these tags. And then you end up with a top-level directory looking something like this. So I'm assuming you've got the code, and then the additional software you need to compile it, or that we're going to use to compile it, is Microsoft Visual Studio, and we're going to use 2019 in this case. And we're also going to use the Intel Parallel Studio XE compiler, both for Fortran and C++. And yeah, I think this process probably works with the C++ compiler for C++ compiler MS Build that's in Parallel Studio. But in general, reading around, it seems that Deltares use the Intel compiler for both Fortran and C++. So we're going to follow that approach. So yeah, it discusses the Fortran compiler here. Yeah, you'll need a Python as well. What's not mentioned here is that you need a .NET framework installation as well for everything to work. So you'll need one of those. So I'm going to put all these links in the video description, but I'll just go through where you need to go. So yeah. Download Visual Studio. You can use the community edition. You don't need to use the Pro edition in this case. So visualstudio.microsoft.com. Parallel Studio is available from intel.com, and you're going to need this video is for using the Fortran and C++ combined conversion. You can get them separate, but yeah, this considers using both. A Python distribution, I would recommend Anaconda because it's really easy to install and remove and get to work. So in general, you don't need Python to actually to actually compile Delft3D, but it is useful for preparing the compiler. For instance, the script I've created, which is a modified Deltares script, builds the solutions for Visual Studio, and also there are a few. There are interfaces to Delft3D that are run through Python. So it's useful to have a Python distribution, and is pretty critical for this tutorial. So I have Python installed. I have Visual Studio already installed. The last thing you're going to have to get is, like I say, my modified script. And you can go to gist.github.com/horse. And you want this prepare sln_auto.py. And yeah, you can just download this as a zip file. I've got this already. So just to show you what I've got. So I've got my shortcut to my Delft3D source files. This is where I've stored Parallel Studio XE. I'm going to install that. And this is my updated script. And then generally this is mostly what you need. You might, as I say, if you don't have a .NET Framework Developer Pack installed. So you can just Google this. It's at .NET.microsoft.com, Visual Studio SDKs, and then you need to go down a little bit and find one of these framework packs, and you can use any of them. So I have the installer for Visual Studio Community 19 open now, and I have it already installed, but this is just if I were to modify it. I just want to show which components you will need for building Delft3D. And in general, a lot of it's covered by simply finding this desktop development C++ and ticking this box. And then there are so these are the defaults that are selected with that box. And then if you look at the Deltaris website again for the source code, you will see that there's a couple of extra things that should be included. Most of these things, and you can't worry about these Intel bits for now, but most of these things are selected when you choose desktop development, but you need to add C++ MFC support. There we go, and C++ CLI support, and there you go. You're done. That's enough to get you going. It talks about the Windows 8 SDK, but that's not available, and the Windows 10 SDK seems to work just fine on its own. So you can install all of that. It'll take a while. Once Visual Studio is installed, and not until Visual Studio is installed, you can then install Parallel Studio XE. And it's important to go this way round because unless Parallel Studio can find the Visual Studio installation, it won't integrate properly. So if you go to your Parallel Studio and the folder that you've created, and then click install, and then it should find the Visual Studio installation. Okay, so it says here that it's installing the Visual Studio 2017 and 2019 integration. I just have an SDK for 2017. But this is what we want, and then this can take a little while as well. Okay, so it says it's installed. Gives you some instructions about how to set it up for using the command line versions. Not too worried about that right now, so I'll just close that. And we can check whether it's been installed by opening Visual Studio. So once Visual Studio is open, you can just click down Continue Without Code. And then what you can do is, the fact you have Intel things here is a pretty good sign. You can go to About Visual Studio, and then you can look down here. Okay, Intel C++ compiler, Intel Visual Fortran compiler. So if these things appear here, then the installation has gone correctly. You are ready to go. So the next stage is to prepare the files to open in Visual Studio, and to do this you use a Python script, and this is the approach used by Deltaris. I've lost the folder. Here we go. So if you go into the source, the src folder, you will see a Python script called prepare_sln.py, and essentially this thing lets you configure a certain number of settings for your system, and such as the Visual Studio version that you have, and the parallel the Intel compiler that you have, but it only goes up to 17. So my contribution here is to create an update to this script that doesn't have a graphical interface. It just automatically finds your the components installed on the machine, and will set up the solution files based on what it finds. So we need to move this file into the Delft3D source code. So I'm just going to copy and paste, put it into this src folder. And there we go. And now we need to run it with Python. So I'm going to find an Anaconda prompt, which gives me access to Python. And I'm going to change to this directory and run this file. I'm just going to check Python is working, which it is. Okay, and then I'm just going to type Python and prepare _sln_auto.py and press enter. And there you go. So it reports that it's found Visual Studio version 2019, .NET Framework 4.7.2, the Intel Fortran 90.1, and Parallel Studio XL version 20. The blank on the solution path just means that it means it's in this current directory. You'll now see inside your source directory a number of these Microsoft Visual Studio solution files, and this is the main Delft3D one, but we're going to look at the flexible mesh, so dflow_fm_open, and we're just going to double click, and this will bring up this solution in Visual Studio. Okay, so we have the dflow_fm solution open now, and I just want to describe why we needed this alternative solution preparation script. So for domain decomposition, one of the options that Delft3D happens is allows you to use is this PETC module. And this PETC module is quite challenging to compile in Windows. So essentially they provide a predefined DLL, but that DLL is compiled against an older version of the Intel compiler. So when we try and use the new Intel compiler libraries with this old version of PETC, then it breaks down. So we basically have to disconnect this from the system, and that's what the updated script does. So for instance, if we look in the source files for the dflow_fm kernel, you'll see that the solve PETC module is off. So there's also an issue with netcdf, where we have to change one of the values in the header files for the Fortran compiler. So if you can go into netcdff and find in the header files this nfconfig.inc file and just open that up, and then at the very bottom of this file we see this have ts29113 support, and we need this to be defined rather than undefined. So if we just change this undef to define, then this is going to work as we need it. So let's save that. And then we can switch the system to release to x64. And then let's just try and compile this on its own. So right click build. So the build succeeded, which is good. Had some trouble connecting to the internet there, which is why all of this went wrong. And I fixed that. So now we can go ahead and build everything. So if you just right click on solution dflow_fm and click build, and wait a little while, it will build. Okay, so that build took a good 10 minutes or so on my i7 4790. So depending on your equipment, it may take more or less time. There's a whole bunch of warnings generated. This is pretty normal, 226. As long as there's no errors, you should be okay. We're going to test if it's worked. So I'm just going to use this Anaconda prompt that I have before, and we can just go into the bin directory. I tell you what, let's have a look here first. So bin x86 Delft3D FM scripts. Okay. I will put a note of where you have to go. So it's a bit easier. So let's just do this. So cd bin x64 Delft3D FM /scripts. Okay, and then we can just check if it will respond at all. So run Delft3D FM.bat. Okay, yes, you can have access, and there you go. Now, if you want to get this script to run with an input file, an MDU file, it's best if you run from the folder where the MDU file is. So I happen to have one here, so I'm just going to copy and paste the address and move over to this folder. So cd. There we go, and then I'm going to have to call the script from this address. So I'm going to copy that. Run Delft3D, and then my input file, which is flowfm.mdu. And there we go, it worked. So the compilation has been successful. So finally, I'm just going to recap everything that we've done in this video. I'll discuss the requirements again to start off with. So you need a the Delft3D source code, and it's best to get a tag for one of those from one of the tag folders, as they should be the most stable. So you're going to need Visual Studio 2019. The Community Edition is fine. And when you're installing it, remember to select the desktop development with C++ workload, and include the optional extras, the C++ MFC and the C++/CLI support boxes. Make sure those are checked. You're going to need Intel Parallel Studio XE, and I used version 2020. And make sure you install this after Visual Studio is installed to ensure the integration works. If you don't have a .NET Framework Developer Pack, also install one of those. You're going to need a version of Python, and Anaconda Python is a good option, and I'll put links to all of these in the video description below. Finally, you need the Visual Studio Solution Preparation script, the modified version that I have created and is available on GitHub. That script is called prepare sln auto.py, and it's an updated automatic version of the Deltara script, which is called prepare sln.py, that you'll find in the src, the source directory of the source code, and it's modified to work with the latest Visual Studio and Intel compilers. So that's 2019 and 2020. It doesn't require input from the user, unlike the original Deltara script, and it also automatically disables the problematic PET-SC module or PET-C module, where a precompiled version, a DLL, is packaged in the source code, which isn't compatible with the latest Intel math kernel library, which causes it to break. And finally, it also uses the Intel compilers, so the C++ compiler for all the C++ code, whereas the Deltara script relies on MS Build, but they say they use the Intel compilers for both their Fortran and C++, so this does the same. So to run it, you simply open a command window where you have Python available and type Python prepare_sln prepare_auto.py. So this should generate a bunch of solution files, which have .sln extensions. So you need to open one of those in Visual Studio. If you just double click, and the one I opened in the tutorial was dflowfm_open, and that's for compiling the flexible mesh version of Delft3D. But before you can compile, you need to make one more adjustment, and that is to adjust some of the flags for the netcdff interface. So yeah, you need to open a solution explorer to find the header file that needs to be edited, and you go through the folders third party open, netcdff, header files, and then the file is called nfconfig.inc. So you can double click that to open a file and then edit line 99 to make sure that they have TS29113 support flag is defined rather than undefined, and then save the file. You need to make sure you change the solution configuration for Visual Studio to release, and x64. It doesn't work for 32-bit. And then finally, from the build menu, you can select build solution, or you can right click on the solution in the solution explorer and select build. So compilation can take a while, 10-15 minutes plus, but once it's done, you'll find execution scripts added to the directory that I've described there. So that's there's a bin directory created in the src folder, and then under x64 Delft3D FM scripts, there are a few scripts that get added. Now to test those scripts, you can either go into that directory and run them, but it's probably better to go to a directory where you have an MDU file prepared, and then to run it, you would call the run_dflowfm.bat file from the scripts directory, use the full path, and then give your MDU file name after that. And then if it works, the simulation should run and you should see the output. So that ends this tutorial. I hope that helps. If you have any issues going through this, then leave some comments below and I'll see if I can sort out any issues you have. I hope you enjoyed your tutorial.